Okay, so the equation for least squares, y represents the final exam score and x is the score in the first test. The first test score is so x is the score on the first test. The first test score is the explanatory variable x. I think that's right. Manager of a water park collects data on the daily high temperature and the number of customers entering the park for 15 summer weekdays. Based on these data, he produced a least squares regression equation. There it is. On one day, the high temperature was 93 and 1,700 customers entered the park. That's an actual value. Okay, so let's plug in 93. Which of the following is the residual for this observation? So let's plug in 93 right there. So let's go to a calculator page. So negative 3.0 plus 51.2 times 93. Whoops. So I meant to put negative there. Okay. So our predicted is 1651, so actual minus predicted, so 1700 minus that is 48.4 positive. It's a positive residual because we under predicted, right? The actual was more than what we thought. Scatter plot display shows the relationship between carbohydrate in grams and protein content in grams for 17 different Subway sandwiches. 2 points at the far right, indicated with open circles, represent the meatball marinara sandwich and the applewood pulled pork sandwich. Sound good? If these 2 points were removed, how would the correlation change? So the correlation, I guess the original might have been, I don't know, maybe something like this. I'm not sure. But then the new one, without these points, would probably be like this. So those points were kind of out of the way. They had a high residual. So I think the data is better modeled now. So I think the correlation would decrease and the slope would increase. This is the new slope there. Slope would increase. So it's got to be B. Intensity of light bulb is related to the distance from the bulb. Engineer collected data on the amount of intensity measured from various distances. Here's the data. Oh, just write the equation. So this guy is x is distance squared. Does that say squared? Ooh, barely see. Okay, so I guess that's negative 2 power. So right away, it's this one. Okay, so the slope is going to be right below the word constant. So, I mean, the y-intercept is going to be the constant. Right below that is the slope. All of this makes sense. It's predicted intensity. That makes sense. So this is always x right there. If I read that right, that's negative 2 power. Okay. The correlation between the age and height of children was about 0.7. So we know it's positive and moderately strong or moderate there. Suppose we use age to predict the length. We can conclude that. So r squared, in my head, I think would be 0.49. So about 49% of the variability in y can be explained by x. So variability explained by the least squares regression line is 0.49. Percent of variability in height, which is y. Yeah, I think that's right. If it was just r, it'd be, you can tell it's positive and moderately strong. Copy machine dealer has data on the number of copy machines at each of 89 customer locations and the number of service calls in a month at Y in each location. Here's the summary. So we need the two equations. So we have the two equations here from the formula sheet. So let's plug in. So B equals R, which is 0.86, times S sub Y, which is 3.8, divided by S sub X, which is 2.1. So let's get that first. So 1.55. Okay, so now we're going to plug into the equation here. So we know Y bar is 14.2 equals 1, or we don't know A plus 1.556 times X bar, which is 8.4. So now you go to the solve command, menu 3.1. So 14.2 equals A plus 1.556 times 8.4, comma X, comma A. So 14, did I put 0.2? I think I put comma too. Yeah, that'll mess you up. So 1.1296. Oh man, what did I do wrong? So it helps to read the equation, the question. I was trying to get the equation, figure out A and B. What is the slope? Well, the slope is 1.556. So I think I had that like 2 minutes ago. So sorry about that. Read the question. Which of the following would provide the evidence that a particular model describes the nonlinear relationship between a response variable and exponential? So we want it to be nonlinear. So you're looking for a curve pattern in the residual. That's it. I don't think I have to read the rest. That's the number one thing. Least squares regression analysis of the pulse rate is here. Below is a computer output. So the average weight is 550. Use information from the to predict. So let's write the equation here. So y bar, equals, so the y-intercept is 2.298 plus b, which is negative 0.20099 times x, which is log weight, the log of the weight. I'm glad I saw that. It was the log of the weight. Log of the pulse rate versus that. So this is log of the rate, the pulse rate. Ooh, okay. So 550 kilograms, so we're going to plug that in there to this equation. So the great use of the solve command. So log of y, I guess, equals 2.298 minus 0.200 times log of 550, comma y, I think we're solving for. Let's see what it did. So that was interesting. I took my calculator out of, I was in non-cast mode. I put it back into cast mode and used the solve command instead of nsolve, and it gave me the answer. So it's interesting. I didn't expect that. Maybe nsolve doesn't work with log. I didn't really know that. Which of the following statements concerning residuals is true? The sum of the residuals is always 0. That's true. Usually for studying the fit. Plot of the residual plot is for assessing the fit of the, that's probably true. The value of the residual is the observed value. Predict from the least squarish. So the observed value minus the value of the response that one would predict. So actual minus predicted. True. That's just, okay. So all those are true. Yeah. Because that could be like, it just means you got all these points. There's value way out here. It could be influential. It may not be. It might be in the line that it doesn't have to have a large residual. Can you predict a person's shoe size from their height? Okay. Computer output below provides information and regression analysis for 12 randomly selected students. It's a correct interpretation of S. So S is the standard deviation of the residual. So the typical residual measured in centimeters, I guess. Okay. Observed height and the mean height. No, I don't think that's it. Distance between observed foot length and the mean foot length. Not the mean, no, the predicted. Typical error, predicting a foot length from mean, some of the squared deviations now. I guess it's C. Let's check that one. 10 is C. Yeah, that's the best one. I don't love the wording, but it's the best we got. The table and scatter plot below describe the relationship between latitude and average July temperatures in the 12 largest U.S. cities. Looks kind of negative there. Where y hat is predicted July temperature. Okay. Interpret the slope. So think of that as that. So every time I'm just going to say this, I don't know if I'm going to write it. Every time the x value, every time latitude increases by 1 degree, the average July temperature decreases by 0.782 degrees. Predict the average July temperature for Detroit. So Detroit is 42 for latitude, so you're plugging in 42 right there for x. So do 106.5 minus 0.782 times 42. I would predict 173.656. Wait, that seems weird. Okay, so let me see. So 206.1. I see the error. Like, that's too high a temperature. Doesn't make sense. So 73.656 sounds about right, is what we predict. And we want to show that work that I just did on the calculator. Find the value for the residual for Detroit. So that's our predicted value. So actual value for Detroit was 74. So 74 minus that predicted is 0.344. Again, you want to show that work. And the measurement is 0.344 degrees. Find the value for the residual, show your work. Interpret the value of the residual. So interpret the value for the residual. So it's positive, which means we under predicted. The actual value was 0.344 degrees. greater than what our prediction was for Detroit for the average July temperature. Shown below, explain how the residual plot supports the use of a line as an appropriate model. So that's scattered. So because the residual plot is scattered, it is a good linear fit. Phoenix has a very large positive residual. I guess that might be Phoenix. Would the slope of the regression line change if it were removed from the data set? If so, in what direction? So I'm guessing that could be Phoenix there. So if that was removed, I would probably do that. So the slope would decrease. Would the slope regression line change? Well, it kind of depends. So, I mean, it's more of an outlier, so it might not affect the slope that much. It might decrease the slope a little bit, but it might just be like the whole thing moves down a little bit. Let's see what they say for this one. So that was E. But as a large positive, if so, tends to pull the left portion of the line. So because removing this point, that would increase the slope of the line, bring it closer to zero. Would increase the slope. Oh, yeah, it would bring it closer to zero. So that's what I was doing here. So that line would be the new one. So except that's not a, yeah, I was thinking it was decreased, but it's actually an increase because it went from a pretty large negative number to a smaller negative number there. Oh, that's tough. It's a tough one. Calculate the R-squared value. That's the R-squared value. Oh, I like this question. So how do you find R from that? Well, you take the square root. Oh, wait, no, I'm sorry. Well, let's just do that just because they didn't ask it, but they might. So R is actually not positive because the slope is negative. R is negative 0.52. Okay, they didn't ask about that, but oh, they did G. That's G. So G is negative 0.52. It's negative because the slope is negative, and so you have to realize square root doesn't tell you whether it's positive or negative there. Interpret the R squared value. So 27.7% of the variation in average July temperatures can be explained by latitude in a linear model. It's the script that we learned. 12 is a relationship between year and school and junk food experience, okay? So identify the explanatory variable, that would be year. Well, let's see, because we think the year in school would help predict or explain the type of snack you like here. It may not be true, but it might. Is there an association? No, there is not an association. You want to say yes or no for association for this. Because all of the percentages for each of the snacks are the same. It doesn't matter what year you are in school. You like snacks equally as well for each particular snack. Elderly people have difficulty standing. Their heights have the measurements to a study predicting overall height. Wait. So study predicting their overall height. I hope I don't get to this age where I can't even stand. Okay. So from knee to overall height. Here's the data. Okay. So we're saying knee height is this guy. Knee height. I have very little room to make this scatter plot, by the way. I should have made this better. So it looks like I need from 43 to 58. 43, 45, 47, 49, 51, 53, 55, 57. And I said that was knee height. And then overall height. Overall height. That's terrible, but I don't have room here. Needs to go from 145 to 195. 145, 155, 65, 175, 185, 195. Terribly sloppy. Sorry about that. So 57.7 and 192. Somewhere up there. 47.4, 153. 47.4, 153. 43.5, 146. 43.5, 146. Positive here. 44.8, 163. And 55.2, 169. Okay, that looks like a scatter plot. Is there a clear explanatory variable? So yeah, knee height is for sure. We're trying to predict the height. These people can't even stand. So we're trying to make a prediction of their height. Based on the scatter plot, describe the relationship between knee height. So you would say, and use the words, the relationship between knee height and overall height is positive, strong or moderately strong, and linear. And no obvious unusual points here. I don't think, at least for my graph. Use the calculator to find correlation R between knee height and overall height. Explain how this value confirms your answer to part C. Okay, so if you use your calculator, so we'd say knee and overall. So knee is 57.7, 47.4, 3.5, 8. Fortunately, it's not that many numbers. 192, 153, 6. And hopefully I got them all in the right order. Okay, good. So you could do this on a calculator page. I'll just try that. So menu 6, gotta be 1, 4. So what was the question? What is R? So R is 0.87. So we said it was positive and strong. It doesn't say it's linear, by the way. R only tells us two things, strength and direction. And so that confirms those two things. Would R change if the overall height were reduced by 5? No. Knee heights were measured in inches. Any kind of conversion doesn't change R. In fact, I don't know if you've seen this before, but it's kind of neat. So let's graph it on data statistics. Knee. I don't know if I showed you this before. So we're going to do the analyze and go regression A plus BX. Okay, so R squared is 0.76. So if I change this to over, make that predicted, or the explanatory, doesn't change R squared. R doesn't change. It's pretty resistant to those kinds of things, so it doesn't change for those. Suppose a 6 elderly man with a knee height of 57 and an overall height of 150. So that's like, oh man, down here somewhere. Oh, is included. What would on the value correlation? This has a very large residual, right? So, I mean, it probably affect the line a little bit. It's going to be, it's not even really it's within the X value, so it's not like a high leverage point. I guess it'd be an outlier. How would it affect the correlation? So correlation was 0.87. It's going to go way down, right? Closer to 0. It's not going to be as strong for that. Here are the answers. Yeah, reduce the correlation. Okay, that's it for today.